Hi y'all, in this video we're going to start working on the unit circle. We are going to spend a lot of time this quarter thinking about the unit circle, so this is finally getting into that. The unit circle is just a circle of radius 1 centered at the origin. So here's a picture of the unit circle. And what we want to imagine is there's some point, we're just going to call it P to have a reference, that is stuck on the outside of the circle, but it's free to move around either direction. So P could be anywhere on the outside of the circle. And we want to work on building up relationships between its X and Y coordinates and also the angle that would point you in the direction of P or the arc length on the outside of the circle. So let's see if I can fit this with my big pen. Okay, so we know this is the unit circle, which means this is always 1 unit. We already know about X and Y coordinates. X is our horizontal distance and Y is our vertical distance. And now we want to consider two different things, which we'll tie together shortly. Hopefully I can write this little. The angle in here we'll call theta. I don't know if you can see that. Hold on, let me see if I have a finer point pen. I don't. Okay, so just imagine there's an angle theta in there. And then this arc length is going to be called T for now. So we want to think about relationships between X and Y and theta and T. And I want to start actually with the relationship, well, not quite, I guess I have one more in here. So first we can say relationship between X and Y because we actually already know that. We don't need to do anything. We know that if we're on a circle of radius 1, that our point XY is always exactly 1 unit from the origin, which means this triangle will always fit the Pythagorean theorem x squared plus y squared equals 1. So we do have a really nice relationship between X and Y already built up, and we don't want to forget about that. We're not taking that away. Okay, so back to what I was saying I was going to talk about first. I'd like to establish really early on here the relationship between T and theta. So you want to remember that we're on the unit circle, which means if we take the arc length formula, S equals R theta, it actually breaks down into something really simple and nice. We're calling the arc length right now T, so it would turn into T equals, and then R is 1, and theta is the variable we're using for angle, which means T is equal to theta. So this is really nice. This gives us a couple of different ways to visualize things on the unit circle. What we're saying here is that arc length and angle in radians are exactly the same. They take on the exact same value on the unit circle. So if you're picturing pi radians, that would be halfway around the circle. And if you're radians, so let's do angle, halfway around the circle. And if you're picturing arc length pi, it should land you in the same point. So for example here, again, kind of going back to what I was just saying, if you go all the way around the circle, this is a circle of radius 1, its circumference, so remember circumference is 2 pi r. Since our radius is 1, for this circle, the circumference is just 2 pi. So just like we would get radian measure 2 pi on a rotation that took us all the way around, if we measure distance around the outside of the circle, 2 pi lands us in the exact same spot. And we are starting standard position, so always starting from 1, 0, positive angles start by going up, negative angles start by going down. If we go halfway around the circle, that's the one I was just talking about. So halfway around the circle, if the entire circle has a circumference of 2 pi, then going halfway around the circle should be exactly pi units. So once again, the radian measure angle would be pi, and the arc length that corresponds to that is also pi. So we have, again, just this idea that when we're talking about the angle, we can also visualize it as an arc length, the distance around the outside, if we're on the unit circle. Okay, so now what we want to start working towards is not just relating x's and y's, which is fairly easy, and t's and thetas, which is fairly easy. We want to try and get back and forth between the two. X and y are our usual Cartesian coordinate stuff, and we now want to say we could also locate a point by knowing either the angle or the arc length, because that gives us a direction, and then we just find the point on the outside of the circle. So, for example, if we want to look at starting at 1, 0, so this is our usual standard position, and heading pi over 2 units around the outside of the circle, and then seeing if we can establish what our x and our y coordinates are. So we know that just like with radians, pi is halfway around the circle, so pi over 2 will be a quarter of the way around. So that puts us right here. So this is a t value of pi over 2, and this point happens to be particularly nice. I can say exactly what my x and my y are. So my x coordinate is 0 and my y coordinate is 1. Okay, so this is what we'd like to be able to do in a more general way. So this isn't going to give us too much trouble if we pick any of the quadrant angles, the ones that land right on an x or a y axis. But it is a little bit more complicated if we talk about arbitrary points in the middle of any of those quadrants. So what we're going to do is we're going to start by defining a function that's job is to do exactly what we've just been talking about. So we're going to define, let's see if I can think of which pens are working. We'll go back to orange. We're going to define sine. It gets an abbreviation, just SIN, not a very impressive one for sine, but all of the trig functions will get a 3-letter abbreviation. So this one is SIN. Sine inputs a t value and outputs your y value on the unit circle. So again, inputs t, outputs y. So this function says, okay, my job, we don't know how to actually do it yet, but the job of this function is if you tell it your t value, it should tell you your y value. So sine represents y values on unit circles. The other one that we're going to start with is cosine. And cosine is abbreviated COS. And cosine is equal to x. So this one inputs t and outputs x. Okay, so again, cosine's job is if you tell it your t value, your arc length or your angle, it should tell you the x coordinate of the point on the unit circle that lines up with that t or theta value. Okay, so just to make sure we're kind of getting the idea of this, I have a couple of examples. So if we are looking for sine of 3 pi over 2 and cosine of 3 pi over 2, we want to immediately memorize the jobs of sine and cosine. So if I'm looking for sine of 3 pi over 2, the 3 pi over 2 is my t value, and the same thing with cosine. So all of the trig functions input t values, arc lengths or angles, whichever way you want to think about that. The sine function is supposed to tell me my y value, and the cosine function is supposed to tell me my x value. So if I think about my unit circle, and I want to travel an arc length of 3 pi over 2, here's 1 pi over 2 at the top, 2 pi over 2, which is pi on the left-hand side, and 3 pi over 2 at the bottom. So this is my point, and once again, the quadrant angles, the ones that land on axes, are really nice. So this is the point 0, -1, which means the value of sine will be -1, and the value of cosine will be 0. So key with the trig functions is the t value is supposed to tell you where you are on the unit circle, and then you are supposed to figure out based on that location what your x or y or some ratio involving x or y are. So the other 4 trig functions are ratios that involve x and y. Okay, one more on this to really try and make sure you're getting the jobs of sine and cosine. So here we want to picture if we start at 1, 0, so standard position, and we travel 3 units around the outside of the circle, so 3 units counterclockwise. we want to figure out what quadrant we lie in. So this is just giving us a t value right off the bat. It's giving us t equals 3. And remember, there's nothing wrong with t not being a multiple or a fraction of pi. So we want to think about this as if t was equal to pi, we would land right here. Pi is approximately 3.14, so we've gone almost that far. We've gone 3, but not quite. So we're really close to the x-axis, but not quite there. So that's my location. I'm in quadrant 2. And if you're sitting at this point in quadrant 2 and you want to find your x-coordinate and your y-coordinate, this again is just getting back to the jobs of the trig functions. If I tell you you've traveled 3 units and I ask you for your x-coordinate, you would use cosine. So the coordinates of this point would be cosine of 3, sine of 3. And that is a perfectly good answer for what are your coordinates. If you want to get a decimal approximation of this just to check and see if it matches up with what we're seeing here, that's great. But this specifically says my x-coordinate is the one that, how do I want to say this? It's the one on the unit circle that's in the direction of 3 radians. And my y value is the one on the unit circle that's in the direction of 3 radians as well. So the calculator part, you do want to make sure you know how to get decimal approximations on your calculator so you can do some of these intuitive checks. First exam is a no calculator exam because I want to be able to test you on some of the memorization stuff, but this is still a really good way as you're learning to check yourself. So there are hopefully on your on your calculator, if not, you might want to go find one. It should have the sine, cosine, and tangent buttons. You don't have to get a graphing calculator to get those. You should be able to get a scientific calculator. You will definitely want sine, cosine, tangent buttons and inverse sine, inverse cosine, inverse tangent buttons. So if we want to check out if cosine 3 really does appear to be fairly close to -1, and if sine 3 is fairly small, fairly close to 0, we can type them in, but there's one thing to be really aware of. There are modes on your calculator for whether you're using degrees or radians. I don't know how clear this is for you guys. My picture's kind of little. So the third row down has radian and degree. And you can see on mine that it's the degree, this one that's highlighted. So we want to be in radian mode for the entire first, like 2/3, 3/4 of the quarter. So go ahead and switch to radian mode if you're not already there. And then you can check the cosine of 3 and the sine of 3. So the cosine of 3 is about -0.99. That's pretty good. We were hoping it was close to -1. And the sine of 3 is about 0.14. So again, pretty good small positive y value. So you can do that calculator check just to see if it really does seem right and to help you get the feeling for what's going on. But again, do think about doing stuff without your calculator for tests. Okay, let's see. I think I'll do a little bit more in this video. Yeah. We'll go for it. So we've got sine and cosine. There are 4 other trig functions. So there's some cool geometric ways to define these, and I'll talk about that a little bit, but mostly I just want to focus on defining these in terms of sine and cosine. So how do you get the other 4 if you know sine and or cosine? Okay, so first one on our list is a tangent. Tangent is abbreviated TAN, and just like all of the trig functions, tangent inputs a t, and it outputs sine t over cosine t. So it is okay to think about this as y over x, but I'll just say later on, when we decide to restrict our thinking to right triangles that don't necessarily have a hypotenuse of 1, the y over x thinking won't work for us anymore. We will have to think sine over cosine. So my advice is to memorize the sine over cosine, and then if you're understanding that sine is y and cosine is x, it should be really easy to transfer directly over to this y over x. Cotangent, abbreviated COT, inputs a t and outputs cosine t over sine t. So cotangent is the reciprocal of tangent. There we go. Okay, so cotangent t is cosine over sine t. It is also 1 over tangent t. There's a couple of potential funny domain things when you use the 1 over tangent as cotangent or vice versa. But for now, just keeping this in mind is a good one. The next one I want to do is secant. Secant is abbreviated SEC. And secant of t is 1 over cosine t. So secant is the reciprocal of cosine. So on the unit circle, it's going to be 1 over your x value. And the very last one is cosecant. Cosecant is abbreviated CSC of t. And it is the reciprocal of sine t. So it's 1 over your y value. Okay, so we have all these trig functions. Really, it boils down to mostly we use sine, cosine, and tangent, and sine, cosine are the really critical ones. If you know sine and cosine, you can get any of the others using these formulas right here. And I'll point out again for later, these formulas that we just built up, they're really important. We use them a ton. There are basic identities for trig functions. So an identity is a statement that is true regardless of what value of the variable you pick. So these all have t as their variable. So this is what I'm talking about, these little formulas. So regardless of the value of t, these should all be true statements. Again, with some small exceptions. This one, right? This was the one I was talking about earlier. Generally, that's true no matter what t, but there are some t's that give domain problems that make it a little wonky, but otherwise this one is true for almost all t, any t that don't give you a domain problem. So these are our basic identities that are true no matter what value of t you pick, and we will use them a lot. We'll use them when we're solving equations, and we'll use them when we're verifying identities. So these are really key. This is one of your big memorization things up front. So first chunk of memorization has showed up here, and that is memorizing what the definitions of the trig functions are. So on the unit circle, what does sine mean? What does cosine mean? And how do you get tangent, cotangent, secant, and cosecant once you know sine and cosine? So memorize all of the definitions and the jobs of the trig function. So definition is kind of the job, but again, sine of t gives you y value on the unit circle, that kind of thing, really important. We've already mentioned that the relationship between your x and your y is given by this x squared plus y squared equals 1. I'm going to switch colors for a bit here. So I just want to point out that we can actually rewrite that using trig functions now. So we know that cosine t should give us our x's, which means if we take a cosine of t and we square it, and then y is given by sine t. So we take a sine t and we square it, and we add them up. That should always give us 1. This is your first Pythagorean identity. There's a few versions of the Pythagorean identity we'll run into more later that involve tangent, secant, and cotangent, cosecant. But for now, this one should get us through everything that we need to know. I'm going to rewrite just a little bit because there is kind of a shorthand notation thing that we do with trig functions. Powers on trig functions are pretty common. So instead of writing it with the extra set of parentheses, we will generally write it this way. I kind of like this and I kind of hate this. I like it because it is a little easier and cleaner to write. I don't like it because so far we've said that you want to be really careful with your notations, because if you take something like f of x to the -1, that really means raise f to the -1st power. But if you take the f and you put the -1 exponent directly on the function, that means inverse. And now we're saying they mean the same thing. So there is this notation thing with the whole inverse business that's a little weird. So I would avoid doing this. If you want a -1 power, use the parentheses, because cosine with the -1 will still mean inverse to us. So -1s are trouble when you're doing notation stuff with exponents. But otherwise, if you see a cosine squared or a cosine cubed or whatever, it means the whole thing is squared. Oh, and I see I put that on a note even so that I wouldn't forget to say it to you. Okay, let's see. let's wrap up a little with this basic definition stuff. I think my video is getting plenty long. Okay, so we did a sine and a cosine of 3 pi over 2. So let's go again and say, okay, we're on the unit circle. 3 pi over 2 units around the outside puts us right here. And you always, unless very specifically told otherwise, start at 1, 0. If you're working with the trig functions, no matter what you think you're doing, they're going to assume that you're starting at 1, 0. And if it's a positive thing you're plugging in, they'll assume you started by heading up. Okay, so we are at the point 0, -1. We already did sine and cosine, so let's just walk through the other 4. So this again just goes back to our fundamental identities. I'm drawing pictures you can't see. Sorry guys, I made marks on my table this quarter and I'm still doing it. Okay, so tangent. Tangent is defined to be sine over cosine. And this is a little bit awkward at first as you're just memorizing what sine and cosine are, but hopefully that sticks fairly quickly. So the value of sine was -1, that's our y. The value of cosine was 0, which means tangent is undefined. So it doesn't actually equal this because that's undefined. So tangent is undefined at 3 pi over 2. If we go for secant, secant is 1 over cosine. And again, you just have to memorize those as quickly as possible. So 1 over cosine, the value of cosine was 0. So we have now 1 over 0, which means, again, this function is undefined. Okay, so not very exciting so far. We're getting lots of undefines. Let's see what cotangent does for us. Cotangent is cosine over sine. So cosine is your x, and that's 0. Sine is your y, and that's -1. So this one finally is not undefined, but it is 0. All right, and then last one, cosecant is 1 over sine. The value of sine was -1, which means this one is -1. Okay, so notice that while sine and cosine are defined for any t value, this is this note right here, so you can no matter what t I pick for you, if it's big or small or positive or negative or 0 or messy, no matter what t value it is, if it's a real number, I can tell you that it's associated with an x and a y. It might be tricky to actually get that. You might need a calculator to tell you, but every t value is associated with a real x and y value. The other 4 trig functions, because they're defined as ratios, they can be undefined anytime their denominator is 0, which means at any point where an x or a y coordinate are 0, you're going to have a couple of them being undefined. So right now we're in this funny little trap where we don't really know what to do if we're not at one of the quadrant angles. So those are the only 4 we're really working on very exactly. But whenever we work on any of those 4, the 0, the pi over 2, the pi, the 3 pi over 2, and then you could continue 2 pi, 5 pi over 2, so on. At any of those, you're definitely going to get some undefines because one of your coordinates 0. So don't freak out if you get an undefined. That's normal, but it really should be only happening at the axes. What's my other note? Oh, signs. Okay, so each function is going to sometimes give you positive values and sometimes give you negative values, and that should entirely depend on which quadrant you're in. So for example, sine is y values. So if you're in quadrant 1, your y value is positive. If you're in quadrant 2, your y value is positive. If you're in quadrant 3, your y value is negative, and in quadrant 4, your y value is negative. Cosine is your x coordinate. So positive in quadrant 1, positive in quadrant 4, negative in quadrant 2, negative in quadrant 3. Okay, so there's the walkthrough with sine and cosine. And from that, we should be able to figure out any of the others. So tangent, and let me point this out right now as well. This kind of ties in nicely. If we're talking about tangent, and we look at our point and we say, okay, it's y over x, it's sine over cosine. Notice that tangent tells you the slope of the line through your point. So that's a really easy way to decide when it's positive or negative, but you could also look at this and say, if I take a positive and divide by a positive, I'm going to get a positive. But otherwise, if you're thinking about the slope visualization for tangent, slopes are positive in quadrant 1 and 3. So if your point is in quadrant 1 or 3, your line will have a positive slope. If your point is in quadrant 2 or 4, it will have a negative slope. So the line has to start at the origin and go through your point. So again, all of the trig functions take on positive and negative values. They can equal 0. The most recent 4 can be undefined. And the quadrant will determine whether you're taking on those positive or negative values. Okay, let me peek what's next. Yeah, I think I'm going to quit there for this one. Thanks for watching.